In the winter of 1947, in a storage room beneath the Budapest Transport Museum, an electrical engineer sorting through boxes of salvaged equipment found something that contradicted everything in the technical manuals. The inventory label, typed on yellowed cardstock, listed the contents as overhead wire components, tram system 1896 to 1945. Inside, wrapped in oilcloth that crumbled at his touch, lay not copper cables or suspension hardware but a set of iron rails, each segment fitted with peculiar copper plates bolted to the underside. No insulation, no mounting brackets, just bare metal designed to sit in direct contact with earth. A handwritten note, tucked between the rails and dated April 1898, read in fading Hungarian, "Ground return system, 600 volts DC, rail negative, no overhead positive required for sectors 7 to 12. The city's official records insisted that all trams since 1889 had used overhead wire systems exclusively. Yet here, physical evidence suggested otherwise. Rain had fallen that morning across Budapest, leaving the cobblestones slick and reflective. The engineer, a man named Laszlo Kovács, who had worked on the city's electrical grid for 20 years, carried the note to the museum's archive. He requested any documents related to ground return or earth current tram systems. The archivist, an elderly woman who had cataloged the collection since before the war, pulled 3 folders from a locked cabinet. Each folder bore a red stamp: technical records, restricted access, ministry approval required. Inside were blueprints, photographs, and installation reports from the 1890s, showing tram lines that used the earth itself as part of the electrical circuit. No overhead wires in certain sections. The current flowed from a central power station through one rail into the tram's motor and returned through the ground to complete the circuit. The system, according to the documents, had operated in Budapest, Vienna, Berlin, and over 40 other European and American cities between 1881 and 1920. Kovács checked the dates against the official city electrical records. They did not align. The municipal archives claim that Budapest's tram network converted to overhead wire systems in 1889 and never used ground return technology. Yet the blueprints in his hands, stamped with city engineering department seals, showed ground return installations continuing through 1912. Someone had amended the historical record. The question was why. On 16 May 1881, in a demonstration yard outside Berlin, the inventor Werner von Siemens stood beside a small electric rail car that would change urban transport forever. The day was overcast, the air heavy with the smell of coal smoke from nearby factories. A crowd of city officials, engineers, and journalists watched as Siemens explained his system. Current from a dynamo would travel through one rail, power the tram's motor, and return via the opposite rail to complete the circuit. No horses, no steam, just electricity flowing through metal in contact with earth. When he activated the system, the tram rolled forward smoothly, silently, without visible power source. The demonstration lasted 11 minutes. The Berlin City Council approved funding for a full installation 3 weeks later. What Siemens did not mention in his presentation, but recorded in his private engineering notebooks, was a phenomenon he had observed during testing. The current did not stay confined to the return rail. It dispersed into the earth itself, following paths of least resistance through groundwater, mineral deposits, and buried metal infrastructure. He measured voltages appearing in gas pipes, water mains, and building foundations up to 200 meters from the tram line. The earth was not an insulator, but a conductor, and it was participating in the circuit, whether intended or not. His notebook entry from 12th of April, 1881 noted, "Ground assumes return function naturally. Rail merely provides preferred path. Question remains whether earth current can be harnessed directly, eliminating return rail entirely." By 1885, the question had an answer. In a test installation in Frankfurt, engineers discovered that a single electrified rail could power a tram if the earth itself served as the return path. They drove copper stakes deep into the ground at intervals along the route, creating what they called earth electrodes. Current flowed from the power station through the positive rail into the tram, through its wheels into the negative rail, and then, critically, into the earth via the buried electrodes, returning to the power station through the ground itself. The system worked. It required half the rail installation of the 2-rail design. It was cheaper to build and maintain, and it was almost immediately suppressed. A memorandum from the Frankfurt Municipal Electrical Commission, dated 3 September 1885 and discovered in city archives in '92, explained the suppression in bureaucratic language. The single-rail earth return system, while technically functional, produces stray currents of sufficient magnitude to accelerate corrosion in underground gas and water infrastructure. Additionally, voltages detected in building foundations present potential hazard to public safety. Recommendation: mandate dual-rail insulated, return for all future installations. The memo was marked confidential, not for public distribution. Yet the same archives contain contracts for earth return system installations in Frankfurt dated 1886, 1888, and 1891. The official policy and the actual practice diverged. Photographs from Vienna in 1897 show tram lines where only one rail appears in the street, with no visible overhead wire. The images, preserved in the Austrian State Archives, were labeled Experimental Ground Return Sector, Ringstrasse Extension. In the photographs, trams operate normally, passengers boarding and disembarking, no visible difference from standard service. Yet, technical drawings filed the same year show underground copper mesh networks installed beneath the street, creating what the engineers called current collection fields. The earth was being engineered to conduct more efficiently, turning entire city blocks into components of the electrical circuit. On 2 November 1899, an electrical worker in Prague named Joseph Novak was repairing a broken water pipe in the basement of a building near the tram line. His tools, metal wrenches and iron fittings, began to heat in his hands. He set them down and felt a tingling sensation when he touched the exposed pipe. Using a voltmeter borrowed from the municipal electrical department, he measured 43 volts between the water pipe and the earth floor. The tram line was 2 streets away. The current was traveling underground, through the earth itself, seeking any conductive path back to the power station. Novak filed a report with the city. The report was acknowledged, filed, and apparently forgotten. 20 years later, during excavation work on the same street, workers found corroded water pipes that had failed prematurely. The corrosion patterns matched those caused by electrolytic action, metal dissolving in the presence of electrical current. The problem was not isolated. By 1905, cities across Europe and North America, that had installed ground return tram systems, were reporting accelerated corrosion in underground infrastructure. Gas pipes developed leaks, water mains failed. Building foundations showed pitting and erosion, where steel reinforcement bars contacted the ground. The earth, it turned out, was not a passive conductor, but an active participant in the electrical circuit, and the participation had consequences. A report from the American Society of Civil Engineers, published in February 1907, documented the phenomenon with technical precision. Stray earth currents from electric railway return systems have been observed to travel distances exceeding 500 meters from source rails. Voltages detected in underground metalwork range from 5 to 120 volts DC. Corrosion rates in affected infrastructure increase by factors of 3 to 15 compared to non-electrified areas. The mechanism is electrolytic. Current entering metal structures at cathodic points causes no damage, but current exiting at anodic points removes metal ions into solution, producing accelerated corrosion and structural failure. The solution, according to the report, was to eliminate earth return systems entirely and mandate fully insulated dual-rail or overhead wire configurations. Yet the report also noted, in a footnote on page 47, that certain proprietary systems employing deep earth electrodes and copper mesh grounding fields, time 500 mistors, have demonstrated reduced stray current emission, though at increased installation cost and complexity. These systems remain in limited use in European installations where overhead wire prohibition or aesthetic considerations warrant their expense. The footnote hinted at something the main text did not fully explain. Some cities were investing significant resources to make earth return systems work better rather than abandoning them. The question was why. In Vienna, a partial answer appeared in municipal planning documents from 1908. The city's historic center, dominated by imperial architecture and carefully preserved aesthetics, had prohibited overhead wires on several prominent streets. Tram service was desired, but the visual clutter of wires and poles was deemed unacceptable. Engineers proposed an alternative: enhanced earth return systems using buried copper networks so extensive that stray currents would be channeled away from vulnerable infrastructure and back to the power station through engineered paths. The plans show networks of copper cables, some over 3 kilometers long, buried beneath streets at depths of 2 to 3 meters. The copper created artificial return currents that competed with the natural dispersal into random earth paths, reducing stray current effects by an estimated 60 to 70%. The Vienna system, according to photographs from 1910, the time 450s, operated successfully. Trams ran on designated routes with single electrified rails and no overhead wires, powered by current flowing through the rail and returning via the buried copper networks. To a casual observer, the trams appeared to run by some invisible force, gliding along tracks with no apparent power source. The illusion was deliberate. City planners valued the aesthetic of wire-free streets highly enough to justify the expense and complexity of the underground system. Similar installations appeared in sections of Berlin, Munich, and Budapest. In each case, the engineering followed the same pattern: designated wire-free zones in historically sensitive areas, time 100 mistinian single rail or dual rail with earth return systems, extensive buried copper networks to channel return currents, and careful isolation of vulnerable underground infrastructure. The systems worked. They were also expensive, technically demanding, and known to relatively few people outside municipal engineering departments. On 8th March 1912, a fire in the Budapest Municipal Archives destroyed records related to the city's tram electrification between 1889 and 1905. Official accounts attributed the fire to faulty electrical wiring in the archive building. Insurance documents listed the loss as primarily historical records of limited technical value. Yet the engineer Kovács, researching the earth return systems in 1947, found references in surviving correspondence to comprehensive ground return installation maps that should have been stored in the destroyed section. The maps would have shown the exact locations of buried copper networks, earth electrode positions, and current return paths, information that could have been valuable for maintenance and future planning. After the fire, this information existed only in fragmentary form, scattered across departmental files, or not at all. In the absence of clear documentation, maintenance of the systems became problematic. By 1920, many cities had begun converting wire-free sections to overhead wire systems, citing standardization and maintenance efficiency. The earth return systems, where they persisted, were gradually forgotten. The buried copper networks remained in place, unused, their locations known to fewer and fewer people with each passing decade. A document from the Berlin Transport Authority, dated 14th June 1928, noted during conversion work from earth return to overhead wire systems on Unter den Linden, excavation revealed extensive copper mesh network at 2.3-meter depth, installation date unknown, original purpose unclear, network left in place, overhead wire installation proceeded per standard. Specifications. The copper that had once carried return currents for an invisible tram system was abandoned underground, its function forgotten within a decade of its decommissioning. During World War II, metal salvage operations in occupied cities occasionally uncovered the forgotten networks. A report from a German salvage unit in Vienna, dated September 1943, described finding large quantities of high-purity copper cable buried beneath Ringstrasse, original purpose unclear, possibly old telegraph or electrical system. The copper was excavated and sent for war material recycling. The salvage crews did not know they were dismantling the infrastructure that had once made wire-free trams possible. The systems were erased without anyone realizing their significance. After the war, as cities rebuilt and modernized their transport networks, the earth return systems passed entirely out of living memory. The overhead wire became universal, accepted as the natural and only method of powering electric trams. Photographs of wire-free streets from the 1900s and 1910s, when they survived, were often mislabeled or misunderstood. Historians viewing images of trams operating with no visible overhead wires sometimes concluded the photographs had been retouched for aesthetic reasons, or that they depicted isolated experimental systems that never entered service. The possibility that such systems had operated routinely in multiple cities for decades was lost. Kovács, the Budapest engineer who uncovered the equipment in 1947, attempted to publish his findings. He submitted an article to a technical journal describing the Earth return systems and their suppression from official records. The journal's editor returned the manuscript with a note. While historically interesting, the technical claims regarding extensive wireless tram operation cannot be verified against available municipal records. Recommend revision to focus on documented overhead wire systems, or provision of additional archival evidence. Kovács could not provide such evidence. Much of it had been destroyed in the 1912 fire, and the rest was scattered or restricted. His article was never published. He retired in 1952 and died in 1961. His research notes were donated to the Transport Museum, where they remained in storage, uncatalogued, until rediscovered in '98. The rediscovery came during renovation work at the museum. A researcher sorting through boxes found Kovács's notes, along with the original copper-plated rails and the 1898 handwritten note about ground return systems. Cross-referencing the notes against newly digitized city archives revealed the pattern: extensive earth return installations, restricted documentation, gradual conversion to overhead wire, and systematic erasure of the earlier technology from public memory. The researcher, a historian named Anna Balog, published her findings in 2002 in a paper titled The Invisible Wires, Earth Return Tram Systems in Central Europe, 1881 to 1920. The paper documented installations in Budapest, Vienna, Berlin, Prague, and Munich, using blueprints, photographs, and technical reports that had survived in scattered archives. Balog's research revealed the extent of the systems. In Vienna, at peak operation around 1910, nearly 18 kilometers of tram routes used earth return technology with no overhead wires. In Budapest, the figure was 12 kilometers. Berlin had converted most of its earth return sections by 1915, but at least 23 kilometers had operated without overhead wires between 1895 and 1914. The systems had not been minor experiments, but significant components of major urban transport networks. They had functioned, transported millions of passengers, and then been deliberately erased from official history. The question of why remained partially unanswered. Balog's paper suggested multiple factors: the genuine technical problems with stray currents and corrosion, the increasing standardization of electrical systems favoring overhead wire configurations, the expense of maintaining buried copper networks, and the loss of institutional knowledge during wartime disruptions. But the pattern of destroyed archives, restricted documents, and mislabeled photographs suggested something beyond mere technical obsolescence. It suggested that someone, at some point, had decided the earth return systems should be forgotten. Today in 24, the streets where trams once ran on earth currents are overlaid with modern overhead wire systems. The buried copper networks, where they were not salvaged during wartime, remain beneath the pavement, unused and largely unknown. Occasionally, during excavation work, construction crews uncover sections of unexplained copper cable at depths of 2 to 3 meters. Time 500 museum, too deep for modern utilities, too extensive for simple grounding systems. The cables are noted in excavation reports as legacy infrastructure, purpose unknown, and work continues. No one thinks to check whether they align with tram routes from the 1890s. In Vienna's first district on Karntnerstrasse, a section of street underwent major renovation in 2018. Workers excavating for new utility lines found a copper mesh network at 2.4 meters depth, covering an area of approximately 800 square meters. The copper was high purity, barely corroded despite over a century underground. A consulting engineer called to assess the find examined the layout and determined it was possibly related to old tram system, though configuration inconsistent with known overhead wire grounding practices. The mesh was documented, photographed, and left in place beneath the new pavement. The engineer's report, filed with the city archives, noted that the copper appeared to form a deliberate pattern, possibly designed to channel electrical current over a wide area. The report did not mention earth return systems. The engineer had never heard of them. If history is a document with pages removed, then the story of earth return tram systems is one of those missing pages. The trams glided silently through city streets, powered by currents flowing invisibly through the ground beneath, and then were erased, not by failure, but by standardization, by official preference for visible overhead systems, and by the gradual erosion of memory. The rails with their copper plates, the buried mesh networks, the technical reports marked confidential, all suggest that the technology worked well enough to threaten the emerging consensus around overhead wire systems. And threats to consensus, in infrastructure as in other domains, are often resolved by erasure rather than confrontation. The Earth remains conductive. Current still flows where voltage differences exist. The same principles that powered trams in 1890 apply today. Yet the idea that a city's streets could conduct electricity, that the ground beneath could be engineered into a component of the power grid, has become unfamiliar to the point of seeming impossible. When electrical engineers today examine the old photographs of wire-free trams, they often conclude the images must show battery-powered experimental vehicles, or that the overhead wires have been removed in post-processing. The possibility that the Earth itself was the return conductor is, for many, literally unthinkable, not because the physics have changed, but because the knowledge has been lost.